Hey, this is Mr. Beckstrom, and today I'm going to look at an example from section 3.1. This is similar to the problem number 11 in my MATLAB homework, and it says for the function and point below, find the derivative, that's f prime of a, and determine an equation of the line tangent to the graph of f at a, f of a, that's the same thing, it's kind of like xy, for the given value of a. So not only do I want to do this problem, but I also want to double check in my calculator to make sure it looks like that's a tangent line, a line that only goes through one point at that given value for x. So let's go ahead and start working on this problem. All right, so in a previous problem that I did, I actually used that a equals 5 value in the beginning of that limit definition of the derivative, which made it a little bit easier, but it didn't give me an equation for the slope of the tangent line. So if I had any other a values that I wanted to check, I would have to go through that entire process again. So this time what I want to do is I want to come up with a general equation for the slope of the tangent line. And then be able to plug that 5 in there at the end, just so you can see both ways to do it. So once again, the derivative, there's actually a couple of different definitions for it, but the best one to use if we're doing this by hand is the limit as h, which is the distance between our a value and our x value on the x-axis. As h approaches 0, that distance approaches 0. We're going to look at f of a plus h, so that x value plus the distance minus f of a all over h. All right, so let's use this formula to solve this problem here. Okay, so in our case, this is going to be f prime of a. Remember, I'm just going to solve the general equation first, so I'm not going to replace the a with the 5 yet. I'm going to do that once I'm done with the getting the equation. So this is equal to the limit as h approaches 0. And then I have f of a plus h. So it says I go to the equation, or the f of x, and I replace x with a plus h. So this is going to be, I'm just going to write that equation down and replace x with a plus h. And that's going to be squared, because I have a squared there, minus f of a. So that's just going to be kind of f of, and in this case, we just replace the x with the a. So this is going to be, oh, I shouldn't have wrote the f down there, excuse me. This should just be 5a squared all over h. Okay, so now I'm going to kind of go around this way. So this is the limit as h approaches 0. And this thing is a plus h, so this is going to be 5. And then we have to FOIL that out. So I'm going to get a squared plus 2ah plus h squared. Right? And then it's going to be minus 5a squared. 5a squared. All right. And then that's going to equal to the limit as h approaches 0. And that's going to be distributing that 5a squared plus 10ah plus 5h squared plus 5h squared minus 5a squared all over h. All right, so remember what we said before. is that we want to basically cancel out, factor out an h on top so we can get rid of this h on the bottom. Because if we started at the top here and we put in as 0 for h, because that's what we usually like to do, we're going to get the 0 over 0, which was that indeterminate form. All right, so here we go. The negative 5a squared and the 5a squared cancel out. And then we have two terms with an h, so we're going to pull that h out of there. So this is going to be the limit as h approaches 0 of pull the h out at the top, and we're going to be left with 10a plus 5h all over h. Now I am going to cancel those out, and then I'm going to go ahead and plug that 0 in for h, which cancels this out, and I'm just left with 10a. And so f prime of a, in this case, is just equal to 10a. So I don't put the limit anymore because I just applied it. I was able to put it in here and get a form without a 0 in the denominator there. So this is my equation for the slope of the tangent line of any value of a. So if I wanted to check different values of a, I just plug it in here. So with mine, at a equals 5, we just plug the 5 in there, and we get, so this means that f prime, that's our derivative evaluated at 5, is equal to 10. I just said 10 and wrote 5. 10 times 5, which is equal to 50. Okay. Now I didn't leave myself a whole lot of room, so I'm going to kind of shrink this up. Shrink this up a little bit and put it off to the side. A little bit more. I did that again. Okay. So now what I'm going to do is I'm going to determine an equation of the line tangent to the graph of f at a, f of a. So I know that a is equal to 5, and f of a is just the function evaluated at 5. So 5x squared, that's a x, so 5 squared is 25. 25 times 5 is 125. So we're looking at the point 5, 125. 125. That's our point that we want. And we have our slope of that line, which is 50. So this sets us right up for that nice formula, the point slope formula, which that is y minus y1 is equal to the slope times x minus x1, where this one right here is x1 and this is y1. All right, so now we're going to have y minus determinant equation. They didn't say what kind of equation, what they wanted in, so I'm going to do it in both point slope and I'll do it in y-intercept or slope-intercept, which is the same thing. So y minus 125 is equal to our slope, which is 50 that we got from this big long formula, times x minus x1, which is 5. So here's the point slope. I'll put point slope formula. However, we usually put it in the slope intercept. So I'm going to go ahead and do that. So y minus 125 is equal to, I'm going to distribute that, 50x minus 5 times 50, which is 250.
No.
And then add 125 to both sides, so y is equal to 50x minus 125 because we added 125 to both sides, minus 125. So you can either put this in your graphing calculator. It's going to be a little easier to maneuver and easier to see if I put this in the Desmos calculator. So that's what I'm going to go ahead and do here. All right. So what I went ahead and did here is I put the original equation. Let me go ahead and make sure you can see those equations. So I put the original equation here first, which is the red equation. That's our normal. I put the second, the blue one, in as this is our derivative. So this is this derivative which gave us the slope, and then using the same points, the one that we just found. And then I went ahead and just put in a vertical line at 5, just to kind of show us where the two first equations should be touching or lining up. All right, so if I'm looking here, let me just move this around a little bit. But all three of these should basically intersect at the same spot right here at 125, which they do. So that looks right. So here is the derivative, that blue line, and notice how steep that slope is, because that slope is 50 over 1. That means we have a rise of 50 units and a run of only 1 unit. All right, if you have any questions, please let me know, and once again, have a great rest of your week. Thanks.